Hey there, Math Club. This is Noah with a Math Club video bonus. In our last episode, Cool Beans, Pete and I discussed Newton's law of cooling, and we ran an experiment to put it to the test. At one point in the episode, Pete walked me through a calculation to make a prediction of the temperature of our water at 40 minutes in. We thought some listeners might appreciate a video bonus to go along with that calculation. I'm going to make use of three different numbers: the ambient temperature of the room, the initial temperature of the water right when you started your stopwatch, and the temperature at 3 minutes in. The water started out at 155 degrees Fahrenheit. The temperature of the kitchen was 71.1 degrees Fahrenheit. And the temperature at 3 minutes was 150.4 degrees. The general form this function takes is y of t equals a plus c times e raised to the kt, where a, c, and k are constants depending on the experimental data. If we use the data from our experiment, we get y of t is equal to 71.1 plus 83.9 times e raised to the power negative 0.0188 times t. I recognize one of the numbers that you just read off in that function, 71.1. That was the ambient temperature of the room. But what were those other numbers in there? 83.9 is the difference between the initial temperature of the water and the ambient temperature in the room. So it's 155 minus 71.1, and we end up with 83.9. And then the remaining number is negative 0.0188. Well, that is called the heat transfer coefficient, and that is that constant of proportionality that is called out in Newton's law. Can you walk me through the calculation I would have to do to predict the temperature at 40 minutes in? Okay, first thing we're going to do is calculate the exponent. So I would like you to take negative 0.0188, the heat transfer coefficient, and multiply it by 40. Why 40? Oh, because 40 minutes. All right. So I'm taking negative 0.0188 and multiplying it by 40. And I believe the answer is negative 0.752. Okay. Now we need to compute E raised to that power that you just read off to me. What's E? E is an irrational number like pi, and it is approximately equal to 2.718 and so on. Okay, e to the power of negative 0.752. That comes to 0.4714. All right. Next step, multiply that by 83.9, the initial temperature difference. All right, so I'm taking 0.4714 and I am multiplying it by the initial temperature difference between the water and the ambient room temperature, and that gives me 39.55. Last step, add the ambient temperature in, so plus 71.1. So now I'm taking 39.55 and adding 71.1 for a grand total of 110.7. Is that our prediction? That is. That's also what I got, 110.7. I'm going to queue up the 40-minute mark into our data file here to see what the temperature was. And 110.8 within 1/10 of a degree. Oh my gosh, that is so cool. We hope you enjoyed this Math Club video bonus, and we'll see you next time.